With the full floor assembly mocked up and referenced, I've rolled it out and I'm ready to finish the prep work on the floor. You can see here I have the relief for the Detroit Speed mini tubs referenced, cut-off tool and seamer ready to cut and fold. When done, I'll be able to simply stand the floor up in the shop out of the way and focus on the trunk area, the QUADRALink and the mini tubs. The trunk pan remains referenced to the frame rails, and I've also dropped in the QUADRALink crossmember. Now I'm going to set this back half of the trunk pan free. I'm thinking I'm going to continue that cut from the back of the crossmember and continue it across here. This gets sectioned out for the mini tub anyways. Okay, before I cut the trunk pan, I popped the frame jig up on the rotisserie because I want to mark the underside of the frame rail for the mini tub. I wanted to see how it all lined up. So you reference the template 14¼ inches back from the spring perch, center it on the other side of the frame rail, mark the frame rail, project the lines up, follow the instructions, and things are looking pretty good. Seems that this line more or less lines up with that doubler plate. So it's an easy reference on both sides. I'll mimic it on the other side and cut the trunk. So I continue to prep as much as I can before removing the existing trunk shock mount. Again, 67 Camaro is the only first gen that has parallel shocks. 68 and 69 have staggered. So closing out this trunk cutout area is somewhat unique. There's a lot of content online dealing with 68 and 69s, but not a lot on 67s. There is some, but they don't really go into specifics how to close out this area. I'm going to take you step by step through that. But another advantage of having the floor assembly out of the car, have clear access to really show you what's going on here, share the insight. So here's the line or the extent of the front edge of the wheel tub, and the back being this frame cutout for the mini tub. So the wheel tub extent is from here to here. Okay. This area gets closed off. Here's the profile of the new upper shock crossmember that spans across frame rail to frame rail, right? And then here, you see how far back those DSC trunk closeouts go. That heavy gauge steel gusset, that triangular gusset that ties into the rear face of the crossmember, all along the inside of the frame rail back to this point. So the combination of the trunk closeout and this heavy gauge crossmember tied together with the frame rail provide exceptional strength to this narrowed portion of the frame rail. So even if you're not utilizing the void the trunk closeout provides, i.e. bringing a 3-inch exhaust system to the tail panel. If you're just dumping your exhaust before the rear axle, I still think, especially if you have a high horsepower application, the benefit of that trunk closeout as a structural gusset to the crossmember and the frame rail, especially in this weakened area, is a no-brainer. So I would highly recommend you looking into that. But having said that, first issue to deal with is this little gap between the trunk and the bottom of the frame rail, and how to close this off on that bit of an angle. So let's get into the detail. I trimmed off a piece of 12 gauge steel, a filler piece in essence, and I scribed it to extend the lip of the frame rail out to meet up with the face of the tub. This would be an open gap. I'm going to tack this along the bottom of the frame rail while I have this in place, because I'm going to be removing this box shortly. But in the meantime, I'm going to just simply take this filler piece, tack it into the underside of the frame rail, and that gives me a clean flush face. The filler plate will get recessed in 1/8 of an inch, so it sits inside that opening and will butt up against this inner piece, and then weld it all along the bottom. I'll be able to weld this lip from the underside, and when I take the box off, again, the beauty of taking the box off, I'll be able to weld from the top face and dress it flat, make sure there's no pinholes. And like magic, the frame is notched and prepped, ready for the infill panel. We'll show you how I go about shaping that. It's basically a straight patch panel, moving right to left until you get to my white mark, which is the start of the tub radius. So I've marked it, and I start to work from the mark going to the left and fold it over at the vise. Let's go to the vise. I draw on a series of parallel lines so that when I begin the curve, it's square. It doesn't trail off in a direction. I simply line up side by side on the line and begin to bend it over just with my hand. And then go to the frame, see if I got the radius. Before I move on to the next line, I make sure that the radius is what I need. So incrementally, more or less line by line, begin shaping it around, validate, and continue. It's pretty simple. Okay, here we go. Slowly working it around on the vise, walking back and forth to the frame rail, fitting it, going back, bending some more, fitting it, bending some more. You slowly work it, and you get the radius you need. Grinding flush. Nice flush face to the existing frame rail. I'll tack it and then tack it underneath, tack it on the side. It's a little proud of the frame rail here and underneath and on top, which is okay, because then I can grind back to my tolerances as I need, and away you go. All right, I'm going to tack it on and move forward. So I took inspiration from the track bar body mount that gets installed on the passenger side. On the driver's side, you have to close out the cross member and mount it to the top of the frame rail. So because I have easy access to the frame rail, because I don't have a floor in the way, I made a similar type of closeout bracket. The only difference with this one, it sits inside the frame rail. So I can plug weld down to the top of the frame rail. It fits inside and locates the cross member, and then I can weld that closeout from both sides because I'll have access to the end of the cross member, and then also I can cap it on the outside. So I've gusseted it so it supports the frame rail on both sides. I can weld through the face of the frame rail, plug weld to that doubler plate, and then similarly I can anchor those gussets to the opposite side of the frame rail. I'll take you to the frame rail and have a look. Okay, driver's side frame rail on the tub side outside. You can see here I've drilled holes so that I can weld to those gussets and anchor it to the outside face. This simply drops in. Oops. There you go. Okay. I'll weld those gussets through the face. On the opposite side, spin my rotisserie around. You can see that doubler plate is located with those plug welds as well. So this sandwiches in between the frame rail. I'll weld down to the frame rail, weld this edge along that new block off plate, and then that perfectly locates the shock member, the cross member in between here. I can weld that closeout from the inside. Similarly, I can go underneath and weld from the underside and properly close out that cross member. It's doubled up, gusseted, strong, welded down. That cross member is not going anywhere. As I'm fond of saying, validation is key in my brain. So to ensure that that new closeout bracket is in the right location, I'm going to mount the front portion of the trunk, the old shock cross member, because this locates the Detroit Speed cross member. Okay, so I have this reference with multiple sheet metal screw holes, so I know it's properly centered and square. Don't have to second guess that. I'm going to put a couple screws in either side, then I'm going to mount in the cross member and validate that the bracket's in the right location, and then I'm free to weld. Okay. Beauty. Okay, that turned out well. Just to show you some of the welds. Haven't cleaned anything up yet. Looking good. Even the beauty of this, I have access. I welded down onto the inside. Down onto the inside. Spin around. There we go. So I'm going to dress those, and if there's any pinholes, which doesn't look like there'll be, but if there are, I'll fill those in, grind it smooth, and come back and show you the final product. Custom closeout plate mounting bracket, fully welded and dressed, looking really good. Very happy with the way that turned out. Next, I'm going to repeat the process on the passenger side with the Detroit Speed track bar body mount. The upper shock cross member is in place. Now I need to locate the track bar body mount. So you see here the underside of the frame is level. My frame jig is level. This cross member is level. And if I take my level. You can see it's also plumb. So perfect, right? And you can see the underside, and I marked the extent from side to side of that track bar mount. And within that track bar mount, I am level. Okay, a little bit of air gap there, which is fine for welding, but it's minimal, right? So for argument's sake, that's level. Everything's level, plumb, and level. Now I'll go over to the welding table and let's look at the track bar mount. So here's the track bar mount. You need to install this so that it's plumb, meaning the 4 bolt holes are square, not tilted up, tilted down. This back, this needs to be plumb, vertical, right? 90 degrees, just like the crossmember box is. And then this needs to be squared to the center, meaning it can't be cockeyed back and forth. It has to be square and plumb, okay? This surface on the crossmember or on the frame rail is plumb, and this needs to be plumb, so this would need to be a 90-degree angle. So with one hand, my nice rusty framing square. Okay, that back needs to be 90, and therein lies the problem, right? Others have run into this, I know, because I've watched them all, but now I need to make a decision. How am I going to reconcile that? Am I going to just butt it in and tack it and then infill a piece on the car, which I don't necessarily like, or on the bench here I can fab up a piece, create some nice clean tolerances, weld and dress on the inside, and prep it properly to weld in. I think that's what I'm going to do, and I'll take you through the process. So this is how I decided to fill in the gap. I took some heavy plate and tacked it in place. All I did was take another heavy plate and clamp it to the face of the bracket because it has such a strong radius. By clamping the plate to the face and chamfering the inside edge of that infill piece, I was able to slide it down low on the radius with it clamped against it, tacked it from both sides so that when it's finished I'll have a clean, flush, dressed face on the outside. But what that affords me to do, now when I go to fit it in place, I can just ease up on this edge and really fine-tune my fit, right? I'll take you over to the frame rail and show you what I mean. So you can see my digital level on the frame jig. We're zeroed in. Okay, now let's come up to this bracket. See, 89.75. So I have to make sure that this back edge is tight to the underside of the frame. Now I just have to grind off a little bit and inch up to the 89, 90. So I'm like 1/4 of a degree off right now. I've whittled away at it a little bit. So I'll just swipe it a few more times with the grinder, keep fitting it up into place until I'm perfectly plumb at 90. There we go. Zeroed in, perfect. 90 degrees, plumb. Now you see, this is why I just put this extension on one side, because now we have to square it up in the cross direction. So now I know it's plumb front to back, right? Now I have to get it plumb side to side. So you can rock this a little bit. If this was a solid mount, flat mount at the bottom, I wouldn't be able to fit it in place. Not to say that you can't do it that way, you can. But see, very subtly, as you see there, 90. So it's just a shade. Can't talk and level at the same time. Okay, 89, 80, very close. Another little hiccup there. I need another hand to tack it. I haven't welded down the cross member yet. I'm just locating it. This is located in place, and now I'm scoring the bracket, and then I'm going to remove the cross member and weld it up all properly. Okay, I'm getting ready to weld in this track bar mount but you have to square it in 3 directions. Okay, so that flange that I welded on to the top, you see I've dressed it now. So by whittling that down and inching it, I know this way, front to back, it's square. So I don't necessarily need to have my level on that. Now, in to out, towards the center of the vehicle, you can see my digital level is on the mount, and that's plumb. But the third direction you have to square up is, the yaw, the twist. And I've done that by clamping this long aluminum level to the face of the mount to simulate the track bar itself that gets mounted across. And then I've used a square across the shock cross member, laid it down, and then I reference the outside face of that level. So I've marked 2 lines on my square. I can transfer, just to be precise, I lay a straight edge on the outside face of here, the outside face of here, my lines line up, and now I can take that same square, take it to the other side, and reference the other corner. Take you over there. So now we're on the driver's side of the jig. You can see the square laying across. So again, reference to the cross member, bang on. I don't know if you can see, bang on, but I'm out quite a bit. So I have to go around to the other side and tap that bracket in at the front corner to push or twist this edge out until it meets the level. Take you around. We're back on the passenger side, still at 90, still flush, clamped in, okay? Everything where it's supposed to be. But now I have to bring this out. I have to twist it, right? So to do that, this is clamped into place. We want to keep this back corner tight. But now I simply have to tap this here, twist it. So I'm tucking that under the frame rail to bring that out. See, getting better. This is almost back to 90. We're good. Still tight under there, right? And we're pretty damn close. Going to go around to that side and double check. But you begin to see how it becomes this trial and error. Get it referenced. Okay, back to this side. Last double check. The square is flush to the outside face of my level. Okay, we're square on this side. I'm going to take the square over to the passenger side, double checking. Passenger side, yep, bang on. Bang on, okay. Oh, my level timed out. Turn the power back on. Yep, 90. That's where she wants to be. She's square in 3 directions. I am going to tack it in place and then remove the upper shock cross member and see what the next exercise in terms of welding it securely brings us. So what's the strategy to weld this in? Well, I figure I'm going to tack it in this corner and then the underside against the frame rail there, and that's going to lock in my side to side angle and my twist angle with those 2 tacks, and then I can remove all the clamps, and then I can focus on the front to back and just revalidate and put my level on that part of the track mount and validate that I have the 3rd dimension accurate. So I know right now with the level and the clamping and I level on this face that I'm good to go. So tack here, tack there, and then we'll come back and validate all our levels and then start welding it in more complete. Okay, I'm tacked in. Everything's been leveled and zeroed out. I'm going to remove the shock cross member and the old shock cross member, get them out of the way, and then I'm going to unlock the rotisserie. I had it locked in place so that everything was level and plumb and square. And then I can spin the rotisserie around and take a better look at the tolerances that I now need to weld and fill. Okay, I'm just about to start welding here. I just want to share a tip with you. So as much as I extol the virtues of Steelit, that weld through paint, I think it is great and tough. It's, you know, as I'm fond of saying, it's almost a, you know, like a powder coating you can weld through. I don't, you know, I use this budget-friendly die grinder I got and put on a burr tip. And anytime I do a spot weld or a butt weld where I have prepped the surfaces with Steelit, I just clean off the edge, clean off the inside of the spot weld with this pointed burr. It takes 2 seconds and I just don't have to burn through the paint. Keeps the smoke down in the shop. Just want to share that little tip with you. Here's the first pass of the infill welds. Looking pretty good. It's fun welding this heavy gauge stuff. Just crank the heat up and away you go. Put a few extra beads here just to fill in the gap. Here was a little sloppy. Started to wet in the sides nice. Spot welds, plug welds, probably will need a little more. So I'm going to spend, as my buddy Elrod would say, a little quality time with the grinder. Knock these things down, clean them up, give it another pass or two with the welder, fill in the low spots or gaps, and we'll come back when it's complete. Okay, very happy with that. Nice and clean and flush. Both sides, flip it around. There you go. Probably going to box that in, close that off. Just looks more substantial. And next, this little front piece. You can see here, I've got a cap. Just going to weld it through the face, all the way around, grind it down, and from underneath. That'll close that off famously and look like one big solid piece. Okay, that's next. And yeah, I think I'm going to box that off. Just looks better. And why do I need a little dust wrap there? Well, that looks better. All boxed in, welded, dressed, looking pretty sweet. Take you around to the other side. All right, nicely closed off, dressed, flush, looking good. Very happy. Okay, next is this closeout on the top. You can see how my inside closeouts mirror each other. That one's on the inside of the frame. This one, of course, is on the outside of the frame. But the doubler plate and the closeout, same vocabulary. Okay, last step before I can weld on the cross member. I have this closeout plate that is going to sit down inside the frame, cap the frame rail between the cross member, weld to the face, weld to the face. The only challenge I have with securing it to the inside face is that doubler plate, especially on this side with the angled gusset, I can't access that side of the frame rail. So good thing the floor is off, so I can weld from the inside. This side gets very tight with the plate on, so I'm going to set the gusset down within the frame rail so that I can tack from this side, and then I'll slip the cap on top and then weld the top edge. All the prep work's complete. You can see here on the passenger side, the flange has been extended. Nice clean straight line for the tub opening. Track bar mount fully boxed in, welded. The closeout mount and the channeled doubler plate inside the frame rail, everything's done, dressed. I'm ready to start welding on the cross members. The first one becomes the stock shock cross member. Goes from here, butts up against this flange. I'll set that in place and we'll come back. The existing shock cross member is in place. I'm going to start welding it down. You can see where I ended up cutting it. I have a nice relief opening here, I can weld not only down to the frame rail through these plug welds, but then also tie the plate and the gusset, which is underneath this joint, tie that to both, and then I weld down the DSC cross member on top, secure it to that doubler plate and to the existing cross member box, and then of course weld it all along that trunk floor edge. So all the welding I can properly clamp down all along and weld along the underside. Easy access on the rotisserie, flip it around, everything's pre-drilled. I'll be able to suck that down and weld, and it will be secure. So I'm going to spend some time with the welder, bring you back when this thing's all welded in both sides.